Hello, in this video I'm going to show you how to take the main aircraft in the simulation tools and adapt it to the geometry that you've produced using CAD software. The steps we need to go through to do this are to replace the graphical geometry with your CAD geometry. Then we need to align the colliders with the new geometry so that the rigid body dynamics for the aircraft works. Then we'll take the aerodynamics and align that to the geometry as well. And finally we'll position the control surfaces on the aircraft. The first thing we want to do is create a prefab of the aircraft. A prefab is like a saved version of the aircraft that sits inside the Unity's project folder instead of in a scene. By creating a prefab, we're ensuring that when the package is updated and this scene becomes a new scene, that we still have a saved version of our aircraft. You can then drag the prefab back into the scene and you'll have your aircraft back. So when we're creating the prefab, the first thing we need to make sure is that we're not inside the packages folder, because this entire folder will be rewritten every time that it's updated. So we select assets from the project window and then we drag the aircraft in and a prefab is created. You'll notice now that the aircraft in the scene is blue to indicate that it is connected to this aircraft in the folder. It's important that anytime you change something, so like if I change the mass of the aircraft here, that you go to the overrides for the prefab, which is at the root of the prefab, and then overrides and press apply all. You can also revert back to the saved version of the prefab in the project if you make changes that you want to revert. So now that we've created the prefab, we can double click on it in the assets folder down here and we'll open up an isolated view of the aircraft so that we don't have anything in the scene obstructing us that we could accidentally click on or block our view with. I also really recommend going up here to the orientation and clicking it so that you're in isometric view, as this gives you the kind of orthographic projections in each axis and it makes things really easy to line up. Another thing that I recommend is the root of the aircraft. Just make sure that that is positioned at 0, 0 so that it properly lines up with the grid if it's not already. So we're going to start with the geometry for the aircraft, so we'll just minimize all the components that we don't need and then we'll get to the geometry, expand that, and we're just going to delete everything inside the geometry because we're going to replace it with our own CAD geometry that we created before. For this example, I've just got a 3D scan of an RC aircraft that I did using an app on my phone. So we'll just drag this onto the word geometry so that it becomes a child of geometry. And the first thing that I notice is that it's backwards, so I'm just going to apply a 180-degree rotation in the y-axis, like this. My aircraft also has a rotation about X. That's because typically Unity's coordinate system doesn't line up with others, but it applies a rotation to make that work. And then the next thing I need to do is just drag the aircraft so that the leading edge lines up with 0. So something like that should do okay. And that's the geometry of the aircraft imported. So then we need to go through and set the aerodynamics, the rigid body dynamics, and the control surfaces. So we'll start with the rigid body dynamics of the aircraft. So this is using Unity's physics engine. So we have a rigid body component on the root of the aircraft, and this rigid body will look for colliders to determine the inertia of the aircraft and how it behaves during collisions. So the easiest way to add a collider for this aircraft would be to double click the aircraft so that we're focused on it and then add a mesh collider to the mesh component of the geometry, and then we need to check the box for convex, and Unity will do like a shrink wrapped collider around that mesh. This will be probably good enough for your inertia calculations. The only downside to doing this is that you might get some strange collisions. So you can see here there are like triangular sections where there's a collider but the geometry doesn't actually exist in these parts. Same between the wing and the tails. So the alternative to this would be to add a series of box colliders around each part of the aircraft. So I'll quickly show you how to do that as well. So if we remove the mesh collider, add a box collider, Unity will make a guess at how big the box collider should be according to the mesh. Then we can either type the size and location of the box into these fields, or we can click this edit collider. We'll get these little squares on the faces of the collider that we can then drag around. Okay, so that's the wing, and then we'll add more box colliders for the rest of the aircraft. So there we go, we've added box colliders to the aircraft, and now the rigid body dynamics for the aircraft will work, collisions will work, and we won't get things hitting the aircraft where it doesn't actually exist. So now we can move on to lining up the aerodynamics for the aircraft, which we can see are these gizmos that are being drawn when we select aerodynamics. So it doesn't matter what order we do this in, so the first thing that we select there was the tailplane, so we'll just go to the transform up here and scale that transform according to the size that our tailplane should be, and then we can move the position and rotate it to give it the correct setting angle. There are local dimensions for each aero object as well, but it's easier for continuity to make sure that all your transforms are the things that you're scaling, not the local dimensions for the aero objects themselves. Try and keep those at 1, and then everything's easy to position and resize. Okay, so that's the tail lined up. I'll show you the wing route as well, and then I'll speed through the others. So the wing actually contains a couple of aerodynamic components. We have a lifting line wing, and we also have an aero object for the separate drag. We don't want to go into here and change the span, because that means that we also need to change the aero object at the same time. What we can do instead is go up to the wing root and then set the scale of the transform there, and both objects will be scaled at the same time. So I know this is roughly 1.15, 1.12, 1.14. So now we have our aerodynamics lined up with the aircraft. The final thing to check is that the fuselage has the appropriate drag coefficients. These can be things that you approximate based on other aircraft or information that you've got from your spreadsheets. I'm just going to leave it at 1. That's probably far too high for the aircraft, but we'll see what happens. So the next step is to add the control surfaces, or to align the control surfaces, sorry. This step, you need to make sure that the control surfaces stay in the same order that they were given in the original model. They're all named in their positions that they should stay in. This is because the control surface is connected to the actual aerodynamics. So for example, this aileron on the starboard side of the aircraft will affect the lifting line element here on the wing and change the camber of the wing locally at this section, and that will affect the lift here a lot more than it will affect the lift over here. So if you were to move this control surface somewhere else, you'd get a disconnect between what's visually happening with the control surface deflection and what's happening in the aerodynamics of the aircraft. So we'll start just by roughly positioning the servos by selecting the entire linkage, dragging the servo where it needs to be. So around there. And then we'll go inside the linkage into the hinge route where we can find the graphic for that control surface, and then we'll resize it. Or if your model has separate components, separate meshes, sorry, for each control surface, you can delete this placeholder and drag the mesh that you're going to be using into the control surface hinge route. So for now, I'm just going to show you this with approximations. So we'll use this mesh here. An easy way to resize things in Unity is this tool here called the rect tool. You can click that and you get these little resize arrows on each end of the object, so that we can just drag it like that. The mesh for this is a bit weird because it's a 3D scan, but it doesn't really matter. So that's where the control surface is. What we need to be aware of as well is where the control hinge is. So if we go back to the move tool, we can see here the x-axis of this hinge is where the control surface is going to rotate around. So if we double click that just to have a better view, and we look side on, it's about that axis here that everything will rotate. So if I apply a rotation like so, you'll see that's where everything moves from. So make sure that that hinge route is at the hinge of your control surface before you move the control surface in. Otherwise there'll be an offset and things won't rotate properly and you'll end up in a bit of a mess. So that's that control surface roughly positioned. Perhaps it needs just moving up a little bit as well. So probably there. Don't worry about the servo cutting through the wing in this model. This is purely for example's sake. You will need to worry about where the servos go in your own model, but that's for another time. So that's that control surface positioned. I'll go through the rest of them now and show you what the finished result will look like. So I've done half of the control surfaces now. Don't be tempted to duplicate these and move them to the other side, because this is labelled within the actual code as the starboard flap, and that means that it affects this part of the wing. Even if I duplicate it, that just means there's going to be two of this flap affecting that part of the wing. You would need to rewire everything in code to get the appropriate effect of just duplicating the flap. So make sure that you move the correct control surfaces when you're doing this. You can duplicate the graphics themselves, so these actual pinky orange flaps, or your own meshes if you so choose, but please don't duplicate the overall linkage system. So that's the controls in position. Finally, we just want to move the propulsion system to the correct place and the undercarriage. So I've selected the propulsion system here. We'll go in and we'll drag it to the front. For this aircraft it's actually up at the back, but we'll pretend that it goes there. And then just make sure inside here we have a battery that needs positioning properly. The speed controller has no mass. There's an airspeed sensor that needs to be somewhere at the front of the aircraft. Your propeller should all be okay. And then the avionics, that's like your autopilot, will need to be positioned correctly inside the aircraft. And we'll be able to see the overall center of mass move as we move all these components around inside the aircraft. So make sure they are positioned realistically. And then the undercarriage, we can move I'm just doing this as a rough positioning, but something like that will do. If the undercarriage is too wide, we can go in and we can select each wheel and then set its position, so perhaps 0.1 and minus 0.1 might be a bit more appropriate. And then your propeller can be set up using the propulsion system settings. So if you select the overall propulsion system, and you can come down here to your design inputs and choose the appropriate dimensions and properties for the aircraft. I'm just going to leave those as the default for now so that we can go back and have a look at what happens. So that's our aircraft complete. We can now go back into the scene view either by pressing scenes up here or the back arrow next to the name of the prefab, and you should see your aircraft in the scene in place of the original aircraft. So we can take it for a test flight, so let's go over to the runway, double click to get the focus back and lower it to the ground. So roughly there. We don't need to worry about setting up the cameras because they were attached to the main aircraft by default. When you do go to update the package, the cameras will be looking at the main aircraft, not your prefab, so you will need to go into this cameras section, and then any of the cameras that you're using, you need to set the target for to be your prefab instead of the aircraft. So that's all fine. Some final tweaks that I'm just going to make to this model are the mass is far too high, so I'll set that to 1, and if we look, the CG is in a bit of an awkward spot there, so I'm just going to play around with the rigid body's center of mass. Maybe that's too far forwards. Something like that give it a pretty high stability, maybe too much actually, minus 0.5. So the aircraft now should be able to fly, so we'll take it for a test flight. And off it goes. So you'll notice that this aircraft's actually being rotated by the reaction torque on the propeller from the looks of it. If I turn the propeller off, it looks so. So that's something that perhaps the inertia of the aircraft is too small, we might need to make that a bit larger, or maybe the propeller is just too strong for this aircraft. But there we have it, it's flying, it's producing quite a lot of drag, because the drag coefficient of the aircraft is 1, but it's in the air. We might need to play around with tuning it, trimming, sorry, but that's how you get your aircraft in and ready to work with.